Just to continue with the seminar, next we will have a presentation by another thesis from the Santa Maria University, Carlos Martínez, just like yesterday. And this opportunity also related to green hydrogen. He will expose on pre-feasibility to using green hydrogen as an energy vector to replace diesel generation. With this, Carlos, please, the microphone is yours.
May I comment before he starts?
Sorry, please.
Just a comment to Patricia that, or anybody else, that if you are interested, I'm happy to work together. So just contact me. You can have my contact from my presentation. Thank you very much.
Thank you very much.
Thank you.
Carlos,
Sí, aquí estoy.
por favor, puedes
Carlos, please. Do you have the sharing screen function enabled?
Déjeme probar.
Okay, let me try.
A ver. Déjeme verificar bien cuál es la pantalla que necesito transmitir. Esta. Ya, ahora sí. Ya. Ahí ve la pantalla completa, ¿cierto?
Sí, se ve completo, Carlos.
Ya, muchas gracias.
Can you see my full screen? Yes, and we can listen to you perfectly. Okay, thank you very much. Good morning, everyone. My name is Carlos, and as was introduced, I am a dissertation student from the Santa Maria University. It's a pleasure for me to participate in this seminar. And as I was explained, I'm going to present about the technical pre-feasibility and economic pre-feasibility to put a hydrogen storage plant. My dissertation process is Professor Patricio Valdivia and Marcelo Cortines. I thanks both to help me to give me all the necessary information to do these studies. Well, which is the scope of this presentation? The first thing I'm going to talk about is briefly describing the study case. I'm going to explain a brief context about the relationship between Patagonia and green hydrogen, explaining the methodology I used to design this storage plant, analyzing different scenarios, and finally a few conclusions. Mr. Marcelo Cortines, who was the booster of this idea, he belongs of this Corfos Integrated Territory Program. As you can see, he's very well updated with the contingent topics in Patagonia. The study case is Ponsombi Valley. This is a very isolated town around 80 kilometers away from Punta Arenas. As you can tell, they don't have access to a distribution network or distribution grid. Besides, a very important datum, in front of this very narrow canal, there are also a few houses. That's very important. That's puts an example. This is a very typical example, very typical case in the area. This is a problem of many towns in that area. Well, how do they supply electricity energy? They have their own generator, 80 kilowatts in a small battery bank. They have a maximum demand projected in 50 kilowatt based upon data obtained from the bid terms and conditions, and demand was corrected up to date through demographic data. Through projection of demographic data, we calculated that maximum demand. Besides, it was projected to install that year in 2016 3 mini wind turbines that are working since a couple of months. Of course, they have an inverter program to prioritize wind energy on top of diesel. That's the idea. The idea is to remove diesel, and they achieved that. And these were the associated costs they had in operation and maintenance before the installation of the wind plant. It's a lot of money considering it is a town with 50 to 60 inhabitants. Then the first question, why to store? They already installed a wind energy plant. Let's describe what's the energy situation like in the Magallanes region. As we can see in this graph, in both graphs, we can tell basically energy consumption is based on fossil fuels, natural gas mainly because they are a producer region, and oil derivatives. The production compared to Chile in the world is quite higher in that area, in the Magallanes area. Then moving the usage of this fuel at a certain percentage will have a huge impact in the mitigation of greenhouse effects. Look at the level of electrification in the country compared to Chile, the rest of Chile and the world is very low. Then it seems to be contradictory because there are favorable winds in the south for generation as shown on this picture. We can see we can find many hectares we may have plant factors higher than 45%, such as the Cabo Negro wind farm that has been working for a few years and they have an average 53% plant factor and they may reach up to 70% in certain years. Then, since there is a natural divergence between wind generation and electric demand, that's why we need to store. In putting storage would improve efficiency in the capital investment in variable renewable energy such as the wind energy. Now, why using green hydrogen? The Sustainable Development Goals by United Nations indicate that energy has to be guaranteed to population, but in a sustainable manner. Now, how do we achieve this? If we study the different strategies the world has taken, developed countries to reach these carbon neutrality goals, in all of them we can see hydrogen is the key pillar to achieve these goals, and Chile is not behind. Chile, as exposed by the ministry earlier this morning, has a very aggressive strategy in terms of being being capable of introducing an hydrogen-based economy in the country. And why green hydrogen? Besides, as we can observe, green hydrogen not only could be used for electricity generation and storage, because it will have an impact on transportation. There are many examples out there that pilot projects are being tested. For instance, ships in countries such as Finland with lots of fjords, like in the Chilean Patagonia, they are already using ships with hydrogen or hybrid between hydrogen and diesel, but it also have an impact in the productive sector because hydrogen is not only used for energy, but it is also part of intermediate processes to produce oil, ammonia, or glass. The impact is noticeable. Another important aspect, something I noticed that goes across all strategies, is make citizens participant to gather the different features of each territory. That's very important because not everyone have the same energy needs and the same energy producing capabilities. Another reason to use green hydrogen is, well, facing the main current competitor, which is for the application I'm studying, is the lithium battery. And we can tell when storing in hydrogen, it has a higher energy density. And we can see in this table, both in energy per mass unit and energy per volume units, we may obtain better results. This is a datum, this is a piece of data calculated in my dissertation, and we can tell in the hydrogen stored in gas format, and this is limited by the maximum pressure supported by tanks. And I calculated for around 40 megapascals, but for electromobility applications, we can find tanks around 60 to 70 megapascal. We can even improve further this competitive advantage compared to batteries. Another important aspect, another advantage of storing with hydrogen is the less amount of waste during and at the end of the life cycle of the project. A problem of a fuel cell is that may generate nitric oxides in the operation, but that could be reduced operating at lower temperatures. And the PEC style fuel cell we think about using operates at lower than 100 Celsius degree temperature, 70 to 80 Celsius degrees, whereas batteries at the end of this life cycle, since they have heavy metals, lithium, lead, if they end up on the earth, on the ground, they will be very, very hazardous for health and for the environment. Another advantage we found in hydrogen is that investment costs are lower. Based upon these tables, these are the costs projected in the short run, a couple of years. They have a component depending on the power I am designing and other depending on the energy. The same for batteries. And this is a huge advantage, this little figure here, because once I already know the power I need to supply, if I want to increase my energy capacity, it's very cheap because basically in an hydrogen based storage system, it is enough having a bigger tank to store more energy. Whereas with batteries, I need to buy more batteries in number, higher number. Then the proposal of the storage system for Ponsonby Valley is having the basic, the inverter with the wind farm and the diesel generator, and with reversible storage system. This is a PEM electrolyzer which may operate in both ways. It means it may receive electricity from the wind farm to produce hydrogen by electrolysis, and it's also capable of feeding it back and injecting energy to the grid. Then, what did we study the different scenarios to find the most favorable? We simulated plexes with the demand data obtained from the studies from the bidding terms. We used data from the wind explorator from the Ministry of Energy for 1 year, and we obtained the diesel displacement we could have dispatched in 1 year without storage. Then we simulated adding storage and then adding storage, and we went further. We also looked at the possibility of how this improved when adding one additional turbine. What if I add two additional turbines? And we also analyzed a different scenario where we concentrated wind turbines in one which is higher power, higher installed power, and operating at higher altitude, expecting to get a better wind profile. And we also simulated what if in the latter case we add storage. What other item do we need? How do I know what size of storage I used based upon simulated data? And we simulated using plexes for dispatching for a full year, and we can tell how in time the status of the load moves. At the end, in Plexo, this is simulated just like a battery. Clearly, using the maximum storage size, using the non-energy wasted criterion, we can tell it is not suitable because look, if we reduce at 90% here, we only shave 3 points. We do not lose a lot. There might be an intermediate point where I may obtain optimum storage. What do we do? We did simulations for dispatch diesel to finally obtain savings in 1 year based on the size of storage maintaining power fixed. Based on this, we obtain these curves with this shape. Clearly, if I don't have storage, I don't have any saving from diesel dispatch. And as I increase storage, I save more. We can tell the shape, and we can also tell how much can we save. In the current status, for instance, with 3 generators and storage, we can save around 7%. more turbines, we can save up to 33%. Furthermore, if we put a more powerful and higher turbine, we may obtain up to 50% of saving. Knowing that shape of saving fuel, finally, we consider that's proportional to the revenues on how much money I don't have to spend to consume diesel. Then what we consider as revenue from the project is the current value of the fuel saving in 10 years. And the investment cost was modulated as a straight line, like the one here, with constant component, since we told that storage had a price depending on the power, and we didn't touch that, and a positive ramp up straight line that depends on the size of the storage. And we can tell to choose the optimum storage, we have to have the same slope. Having this cost curve and the saving curve, finally we can obtain the suitable size of the storage. Using this methodology for each of the scenario, we also did a economic analysis, which was part of the objectives of this dissertation, and this was the results. This is part of what we expected since this is an emerging technology. We didn't expect earnings from this, but we can obtain relevant results in terms of investments because as long as we add as we add wind turbines, we have a lower TIR. That indicates that we are increasingly closer to earn money, basically. That's what indicates it's a better efficiency on the investment. We also did the economic analysis of what if we put a bigger turbine. Obviously, from the economic standpoint, we got worse numbers, but we have to consider what with this latter solution, we can save up to 50% of the diesel dispatch in 1 year. By the way, these numbers are in UF, developmental units, just to use a hard currency. Well, as I said, we obtained 50% saving. In the previous case, we only could obtain up to 33%. Just to wrap up, with all the theoretical study we did, we noticed there's an urgent need of establishing a clean and sustainable economy, and it has to include green hydrogen for sure. And we could notice there's a wind energy pole in Patagonia. There's a lot of potential of clean energies that could be used to produce hydrogen at little or great scale, a small or greater scale, and this because of the positive technical features such as the large storage per unit of volume and the factor of not producing contaminant emissions during the operation and at the end of the lifespan. Hydrogen could be also used for energy storage to couple generation to mass generation with demand, and this allows to increase the usage of the wind resource. And this is very important, given the condition and given the positive properties as an energy vector. It could be used in a local collaborative market because we could tell by itself now they could not only self-supply by clean energies, they will also depend on the diesel generator to have a high quality supply. But if I over-dimension my self-generation plants, I may associate with closer localities. I may change the product. I may change hydrogen basically to supply in time in a continuous fashion, or at least to move more diesel in the worst case scenario. Although it's not economically feasible, we either expect production cost to be reduced in the years. Just to join the words by the ministers, it is now we have to implement this kind of project because we are in an early stage to strengthen the local market for then moving into the international markets. And this would be my recommendation, is adding two additional wind turbines with storage, and with that we could save up to 33% of diesel dispatch. And lastly, to wrap up, we could tell in a later feasibility study, we may obtain better economic results. If we consider my supply plant doesn't need the operation of a transformer and the cost we used, we're considering a sub-transformer because it was considered for big grids and for big power systems. But since we are operating in a low voltage line, this piece of equipment is not necessary, so we can obtain better figures. This is my presentation. Once again, thank you very much for your attention and for your invitation. I hope I was a real contribution to the seminar. Thank you very much.
Muchas gracias, Carlos. Y si me
Thank you, Carlos. If you allow me, Alfredo, are you there?
¿Me permites un par de minutos, por favor,
If
de
you
intervención?
please give me a couple of minutes for intervention.
Quiero referirme un poco muy
Well,
brevemente
I want to briefly talk about Carlos' intervention, given a couple of questions we have received. Yesterday, Alfredo also commented on this. SIGRE this year have boosted a denomination with an important participation in the institution worldwide, and it is called NGN, Next Generation Networking. Basically, this new feature is to link and make networking, and to put together those students of electrical engineering and those young professionals who are just starting their careers, the professional careers, in this new denomination. In Chile, in SIGRE Chile, we wanted to start this year very strongly supporting this initiative by SIGRE worldwide. On each of the meetings we have planned, as it was in March, the one from HBDC, we include the participation of dissertation students who are in the dissertation works. And the idea is also professionals, as just graduated professionals, to participate in this action by SIGRE, because SIGRE for students has a free membership for the time they're students, and there's a call for professors, for leading professors of their dissertations to get close to SIGRE and using this wonderful word of information for them to have a backup for their professional activity. This next generation denomination is very important for SIGRE because this is the cradle for future partners where the institution is going to continue with in the professional career a long time. Then thank you very much, Carlos. Thank you very much, Patricio, who was a booster of having these two dissertation students in this opportunity. And I invite those professors and students who are today listening to us and who can make resonance of this message, who can spread this message, to get close to SIGRE. Doors are open, and as I said, the important thing is for them it is for free, their participation, having all the benefits of a regular professional member with some time of activity or trajectory. Thank you very much, Alfredo, for this advertisement opportunity. Carlos, thank you very much. Before going to the next modules, since we are having question, Carlos, there's a question by the audience. Did you simulate optimization introducing the reduction of CO2 emissions? For instance, putting a price on CO2, simulating the optimum storage based upon that price? We didn't reach that level, but we considered the study of creating in Chile a new carbon market, putting price on emissions. But we considered that as a favorable piece of data for the future, hydrogen to become or to be competitive and not being in the like in the current stage, we have to boost, for instance, necessarily with public funds, because as we saw, it is not economically feasible yet. We started in that level. Okay, thank you very much. There are a few additional questions that unfortunately due to the time we cannot see, but in the presentation, the link, Carlos's data will be available for all participants, and I am sure more many other questions may arrive. Thank you once again for your participation, Carlos, in this seminar.